Welcome to my ramblings. This episode, electrical panel short circuit ratings. Um, During my career as a civil servant working for the DoD, there was a lot of re-engineering, reorganization going on. And, I ended up working in Navy region, South Texas. And so I worked for the Naval Air Training Command. Um, all these, I guess, the military. Um, They have some chief of staff, and then they have a bunch of assistant chiefs of staff, and I guess that was sort of what the air training wing had. And one of the assistant chiefs of staff had his main duties, but he was also delegated to do facilities. So when I accepted a job out at Navy Region South Texas, then again, they don't just call you, hey, would you like to come out here? You have to put in your application. A lot of people don't understand this, I guess, because it just seems like all kinds of people, civilians, military, just show up at the base. I guess, I don't know. I always just assume, well, somebody hired them. They don't work for my organization. I don't have anybody working for me. So, you know, it's not my responsibility to go around, hey, do you legitimately work here? Who do you work for? All that. But so when I got hired, paperwork was signed. My supervisor was the assistant chief of staff. I was a GS-12. Um, that didn't mean that anybody worked for me. That doesn't mean I was involved in the chief of staff meetings and going on. That was I worked in facilities. But so when I get there, first assignment is, okay, we have this thing. Um, I think they wanted to upgrade. I don't remember exactly, but all the projects essentially boiled down to, okay, here's what they have, here's what they say they want, and what the stated issues are. And it all ends up going, okay, well, first thing I need to do is, okay, get some drawings of the existing electrical distribution systems. Um, and usually we didn't have those. A lot of these just an enormous amount of buildings, and during various budget cutbacks and stuff, I guess, some things get left behind, and I guess one of those is keeping up with the drawings. Um, but so that generally means you go out in the field. You go out in the field anyway because you want to field verify what is on the drawings. So you go out and you get information about the transformers, the main power panel, and other panels and stuff. It really just depends. Usually, they'll want to change what the facility is used for, and then you have to make sure that there's enough electricity um, to meet the electrical demands of what's going to take place in the building. And so a lot of the effort is determining, okay, what's the available capacity? Where is that available capacity at? And what upgrades are necessary in order to accommodate the additional or the different loads that this system is now going to be expected to provide. So that's pretty consistent. And you go back to the office, and you take that information, you do the analysis, and what have you, and you check. One of the things I did, like I said, was the load analysis. And I checked that all the ratings are adequate. And when this very first project, and usually what you would do is you say, okay, this is what they want to accomplish. How many different ways are there to accomplish this? Reasonable, that makes sense from an engineering perspective. And then you do some sort of comparative analysis economically. You know, I'm not a trained estimator. Never really had the experience to do estimates. They seem simple enough, but there's a whole lot of factors that go in that I don't really know. And you got to be able to actually know how to design an electrical system or install them. And I've certainly never installed an electrical system. Never was an electrician. My job was, I graduated from college, and they're trying to transition a lot of us recent college graduates in electrical engineering, back in I guess when I first started was in the 1991, and this is like somewhere 2001. These projects that I'm working on, um, you know, but so I would do comparative analysis. I could, you know, if I used the same source for the conduit, the wires, the transformers and stuff, then they'd all be based on the same same thing. I don't want to call it normalizing it, but then I could just compare. It wouldn't give me a good idea of what any one thing would cost, but I could compare. I could compare them relative to each other, and so that's what I would do. And then, from the um, alternatives, uh, I can make recommendations. Say, hey, this looks like the best way to approach it. And, that all gets packaged up, goes off to the ACOS. Actually, I think we have what I call the black hole system, where things go in. They consider a lot of projects, and then they have some committee that says, okay, what are our highest priorities? Which projects are we actually going to push through? But in doing this first one, um, the calculations revealed that the existing electrical panel was rated for some level of short circuit current, but the allowable short circuit current that the transformer would let through is actually higher, and so that's a safety problem. It's a safety issue. If there was a short circuit, 30-phase short circuit, um, and the equipment tried to interrupt it, um, then, well, you have the potential for a catastrophic failure. Doesn't mean that it's always going to fail catastrophically, but it's risk of personnel injury, and it's risk of fire and property damage, and risk of damage to the electrical system. And then you'd have to go and replace it anyway. But so I pointed this out and sent the paperwork in, whatever. And so I think the third one or the fourth one project that I was working on, same thing, another panel, short circuit rating. It's right at the service equipment. The service entrance is where you transition, typically from the utility engineering company, in our case, where you transition from the base electrical distribution system to the building electrical distribution system. That's called the electrical service. So third, fourth project, here's another one, and ended up doing a fifth. So out of 5 projects, there were 2 that had that rating problem. And I think I mentioned it verbally as well, because now I'm thinking, wow, serious. They got a potential, problem on the base, where if one of these things happens to see a short circuit, it could cause some serious problems. So I think I mentioned it to him, as well as putting it in writing. And said, somebody needs to look into it. And I hadn't really heard anything back, and so I decided to launch a project into it and started collecting information. I think there's 88 facilities, anything that has an electrical service. Well, I think 5 or 6 of them didn't actually have an electrical service, but technically they counted as a facility. Because as I would learn, 90% of them are buildings, but a flagpole is actually a facility. So a flagpole doesn't have electrical service. So there's a couple of those, and a couple of signs that had electricity, but 90% of the facilities were actual buildings. And then Corpus Christi has 255. I think I started with Corpus Christi, 255 buildings. Jesus, that's a massive undertaking, and I'm going to have to make sure I have an organized approach to this, so I can get it done in a reasonable amount of time. So I decided to undertake Kingsville first, because, 88 facilities versus 255, I could get my methodology down. That would mean when I went to evaluate the Corpus Christi facilities, it would be much more efficient, and um, you know, I learned organizational lessons at Kingsville and then apply them to Corpus Christi. So I went through, uh, I guess, the analysis. I went and made a visit to every facility on Kingsville, got all the field data, transformers, panels. If it was a large panel, like 400 amps or more, then I think maybe my dividing line was higher. But then I would go look at some of the sub panels as well. And so after all of the analysis, um, I came up with, I think, 7 or 8 buildings that had the panel problems. And I started wondering, okay, well, this is all based on the transformer let through. And so, well, what is the energy available on the primary side of the transformer? Will it be low enough that the actual current that these panels will see will be reduced enough so that it won't actually be a problem? So I did a short circuit evaluation of the primary distribution system of Kingsville. It was kind of involved because they got lines snaking everywhere. So I ended up doing that. I don't remember what the short circuit value was. I'll probably reproduce the calculations and the values in my book, but you can do the calculation that says, well, if I have this much short circuit current available at this voltage on the primary side, how much actually gets let through at the voltage level on the secondary side. And the let through is you tend to think, I want to call it worst case. I don't know where a lot of people got their degrees from. I bring up the issue of worst case. Arguably, I first heard about it when I was taking an extension course to design a microcontroller. Worst case was, some people when they, I guess, early in the development of that industry, people use typical values, and then instead of minimum maximum for the timing cycles and stuff, and then equipment would not run properly. You hit a glitch and it doesn't work. And so when we were designing them, we took in to min maximum depending on which one was popular or which one was relevant. But you can apply that to electrical distribution as well. Worst case is, well, you got to at minimum comply with the National Electrical Code. If your incoming voltage is only guaranteed to be maintained to this level by the utility company, well, if you're designing only assuming that it's only going to stay here, then you might have voltage dips that affect the performance of your equipment and stuff. If the utility voltage happens to go low, worst case design is some of that's built into the NEC when you determine what the capacity needs to be in terms of load for your electrical panel. You can't just load everything up and say, well, on average, the current flow will be less than the rating. What happens when you shut the thing off, or if all the air conditioning switches on, now you got current flowing through it that's higher than its rating, stuff is going to start to melt. And, if you have a short circuit rating that's lower than the available short circuit, things could melt and they could deconstruct in a catastrophic way. That's really the basis of arc flash. Arc flashes, there's so much energy flowing through a piece of copper that the expansion of the copper happens so fast that it's actually an explosion. But anyway, so there was like 7 or 8 at Kingsville, and they were going to reorganize again, and I was going to have to come under NAVFAC, and I didn't even know if I was going to have a job. So I applied for a couple of places, and one of them was Great Lakes, and they called me up and said, hey, I almost didn't want to take it because it was construction contract administration, and thinking, Jesus, I haven't done that as a student when I last did construction contract administration. What is this nonsense about having me rated highly qualified for it? What the hell are they trying to do? Are they getting me up there because I pissed somebody off and they want revenge or something? But no, with the reorganization, I had to, I had kids to support, so I accepted the job anyway. Um, and, with the reorganization, there really wasn't going to be any real engineering work done at the local level, is what I was told. You're basically just going to be the guy that calls, the FX area, region, field thing. Hey, we did this. And that's not the kind of job I wanted. Anybody could do that. And I mean, I should have been happy, food on the table, but so I didn't get a chance to go to the Corpus Christi base, and I actually worked at the Corpus Christi base. So what I had originally intended to do was develop, a sketches to show for each building where these deficiencies were, and but I didn't have time. What I was developing was a spreadsheet. It would have the facility name, okay, columns, okay, for each stage that I got through. I tried doing, okay, just run around, get all the data, then come back and do the calculations. First, I started off, do one at a time, and I realized, it was going to take me a couple of years to get through all of that. So I would go out, one field visit, just visit as many buildings as I could, get all the data, then come back, spend a couple of days doing the analysis and stuff. And then I would use a spreadsheet to track, um, how I was doing. And so what I ended up turning over to the Kingsville base, initially when I started this, I went and I talked to the public works officer. The assistant public works officer, who was a civilian, wasn't there. I told him about the issues, why I thought this needed to be done. And, I think from what I understood when we became part of MNAFAC, if we were able to undertake something like that, that base would have to compensate our command for the time spent. But so so I told him, this is what I want to do. Guys, okay, go do it. When I turned it in, it was, instead of sketches, it was a spreadsheet. But the APWO was there, and I'm kind of thinking I should have gone and talked to the PWO, because when I left that with them there, I'm not sure that anything got resolved. But again, that was 15 years ago. The buildings are probably gone. They probably saw it and developed projects from it, but that bugs me to this day. Anyway, long ramble. Hope you enjoyed it. Just an interesting story, an excerpt from my book. The book talks about it a little bit more detail, goes through all the calculations and what have you. Still writing it though. So anyway, tune in for the next episode.